executes a cell, there's a pop-up window which it does not transmit it to the screen for some reason. Run the cell in advance, yeah, and this one is the same thing, but Shift N and in parentheses Shift Enter. So this executes the cell. I can also turn this off. You don't want to have this. And now one important thing you see is called untitled, and untitled is not a good thing. That's when you save it. Yeah. So if I press Ctrl S, I save it and ask me to rename it. And you give it a name which you can recognize later. That's important, otherwise you have too many things. So now you can write your full Python program. Here you can define a function. So first thing in Python, we define a function, yeah, and you can do something with a function. So this is a function that works, but there's something important missing. What's missing in my function? What's missing in my function? Anybody? The most important thing of a function is the docstring. Yeah? So make it a rule, always write a docstring. So this is missing here, and you write a docstring, and then I have my function, I can call my function. So this first lesson in Python, we find a function with def, and it returns something in between you to computing. It's always a good thing, as soon as you start writing something, it gets longer to put it in the function. Give it a name. Yeah? So you write a command, I do this, I do this, I do this, I do this. This is potentially one function. Yeah? So that's always a good idea to put this in a function. So this is a notebook, and you can write full Python programs in the notebook. It is not ideal to go too far with this idea because there are some notebooks have a lot of advantages, but there's quite a few disadvantages, and you have to take the right tool for the right job. So writing a big program in a notebook is usually not the way to go. The notebook it's a playground to do some small experiments. So the notebook is called notebook because you can also change. Yeah, so this one doesn't work, so probably I need to change the setup here. I can try to. Okay, so I use the full screen, and this hopefully gives me the drop-down menu. Yeah, now I have a drop-down menu. You see, this gives you a drop-down menu. You have 3 different types of cells. Most of the time, it's a markdown cell, as a code cell. As you can see here, those code cells are numbered, and you have an in and output. This is the input, that is the output. This comes from IPython. So the original version, it's still there. That's IPython, which can be useful. So if you have, I make a new terminal. Yeah, I start a new terminal, and in this terminal, I can type IPython to activate IPython, and I have to, since I use Pixie, it's a bit tricky. So see how this works here. Pixie run IPython. So you just type IPython. That's it, because otherwise my environment is not activated. And IPython is part of Jupyter, and that's the original one, and you can do exactly the same thing as you can see here, and it looks just like this. Yeah. So a lot of things I teach you about JupyterLab also work in IPython, and IPython works on the console. So if you need to log into a computer with SSH and you don't have a graphical user interface, then you can use IPython, and you can do quite a few things interactively with Python. It can be very useful. Yeah. And a lot of these things I show you here are part of IPython. The next thing is Markdown. Markdown is not part of IPython, so I can change the type of the cell to Markdown, and I can use Markdown. Yeah, and who knows Markdown? A few people. So Markdown is a simplified markup language. Yeah, and you can write formatted text, simple markup language. Yeah. Useful for notes and so on. Yeah, zack. You can do something like this, or maybe I think in English you might capitalize it, something like this. So you see, I write this markdown, which is very simple syntax. This seems to make a header first order. This man makes a bullet list, and then if I do this and I execute it, it renders into HTML. Yeah. See, there's no numbering, so those markdown cells are not numbered. They don't count into it. Of course, these markdown cells don't exist in IPython. There's no way, because you're on the console. They only make sense in the notebook. So, and now you have this concept, you can combine markdown and code. You can combine markdown and code, and that's what notebooks are good for, because now you can take all your notes in markdown. And this markdown allows you to include figures, links, and so on. So if you want to know more, you go to help, and the help is kind of, there should be more than help than here for some reason. It's not, yeah, I don't know why. But there's a markdown reference, yeah, and the markdown reference gives you a quick run through how markdown looks like, yeah. So that's what you type in. There's always an alternative, and that's what you get out. Yeah, see, this heading 1 goes up to heading 6. 6 £, 6 hashtags give you a heading of 6th order. Then you can have a link, which is important. You can include images and a few other things, bullet lists, numbered lists. And important, you can use backticks to have commands. So very often you write about your code. It's okay, if I type this in, then this happens. And this you write in, if it's a command, you write in backticks. But if you need more, you can write triple quoted backticks. Yeah? And here usually you can write the name of the programming language. So that's Python code, that's a C++ code, this is Rust code, this is Fortran code, whatever language you want, and you can describe it. It's not executed, it's just syntax highlighted, which is nice. Good. So if you want to know more, that's this one. And there's, unfortunately, there are different flavors of Markdown. This is common Markdown. There might be other flavors around, like GitHub uses its own extensions there. Good. So this is important that you have this Markdown written down here. Good. Any questions? So anybody needs to have some basic introduction to Python, or should we focus on the JupyterLab thing? Any ideas? Because now we are not a lot of people, we can customize as long as you get input from you. I can react and do whatever you feel is most useful for you. So who's more interested in Python basics? Python basics. Who's more interested in JupyterLab tools? Okay, so we can talk in the break about Python basics. So as I said, I teach 4 days Python basics, so we'll not cover this anyway. But I can always mention something. So the most important thing, if you do something, always write everything in functions. So if you write a lot of lines of code, because functions are reusable, if you put everything here, it's a one-time thing. As soon as you put in the function, it's potentially reusable. It's not guaranteed, but it's potentially usable. So let's get started. So if you go to the PDF, yeah, that gives you a little bit a rundown. The first thing, you have this magic. So these magics are important, and they also work in IPython, at least most of them. So let's go there, and we do some magics. So if you say quick ref, you get a quick rundown of all these specialties. These are all IPython things. As I said, IPython is part of Jupyter. And you see, you have a lot of these magics included here. So if I type 1%, yeah, so you see now it's a very long output. And if I don't like this long output, I can go with the right mouse button and say clear cell output, yeah, which I don't know why doesn't work. It should work if maybe I didn't highlight this cell. Yeah. So clear cell output. Yeah, now clear cell output. So for instance, you can have ls, which gives you a listing. Yeah, so I have a bunch of stuff in here because I did something. Yeah, then you see ls gives you a listing, and the nice thing is you can use ls in Windows also. So in Windows, it's a different command. Yeah, usually it's a different command, and you can use ls, and ls has options. Yeah, so you can have options, and if you want to know something about ls, you can use a question mark, and you get this is an alias for a system command. If you do the same thing on Windows, it shows you a slightly different command because it shows it Windows equivalent for this. So in Windows it's not colorful because obviously there's no options to make it colorful. No, that's the whole thing. Yeah, and also this question mark is interesting because the question mark, you can say add question mark, and this gives me the help of my function. So add question mark for use any object always gives you the help. Now you get the help, and it's very useful. As you can see the doc string. That's why it's so important to write a doc string, because now I can just say, okay, question mark, what does this function do? And then you write a good doc string. And this doc string is okay-ish, So a docstring typically is a header, and then you write something returns the sum of A and B. You see now I use A and B. So and you have to. This sum is interesting in Python. So now if I use control enter, I can put to a cell. It not only works for numbers, it also works for strings. So this is not very possible in most other languages. In most other languages, they're statically typed. You have to give the type. In Python, you don't provide a type. There's something in Python called type hints, but they are different. They don't enforce the type. You just provide information what type you expect. But there's no runtime control built in Python. It always takes any object. And this function works for any object as long as those objects can work with plus. Yeah? And this plus is not reserved for numerical, for numbers. Yeah? You can also use it for strings, or you can use them for lists or many other objects that work with plus. Yeah? And this makes Python very flexible, because now this list, because you can do a lot of things with it, which in other languages would take you way more work to get there. Yeah? It has other advantages, not ABC add. Yeah? So it has other disadvantages here. I control this. I can delete the cell by going here or press Escape DD. Yeah? Escape brings you into command mode. Now I'm in edit mode, as you can see down there. Yeah? Here, edit mode. If I press Escape, it brings me in command mode, and now my keyboard into typing has a different meaning. It's a modal editor. Anybody used VI? Yeah, this editor on Linux, they have these different modes. They have 3 different modes, and then one mode you type, and other mode, all this keyboard inputs have a different meaning. The same thing here is where I say escape, DD, it deletes the cell. Yeah? So most of the things you can do with these things. If you go here, delete, add the cell above or below, yeah? Add that above, move, and so on. Create a duplicate of the cell, and so can be done here. Yeah? Same goes for here. If you go to the menu, there's a lot of menu entries, and many of them, or some of them, do have keyboard shortcuts, and they're always listed here. Control S to save a notebook. Yeah. So there's a lot of menus. Nobody can remember all of these, but you don't have to. Some of them are very useful to have a keyboard shortcut. So if you use something very often, a keyboard shortcut is good because you're faster. If you use something use only once in a while, then menus are okay because you don't have to remember all these things. Yeah. There's always like something like this, you can interrupt the kernel. So what's a kernel? So this works with a client-server principle. So in this case, the client and the server on your local machine. When I teach with JupyterHub, then the server is some machine I rent in the cloud. The cloud is other people's computer. I rent a virtual computer, install something, and then the execution works here, but the display works in my browser. Yeah, and the same thing works here, and then makes it very useful because now the browser seems to be an own operating system. You can do so many things in the browser, and that's why you have this kernel, and you can have multiple kernels running. And if you go here, you see the kernels, yeah, and you see there's a bunch of kernels running. There's always a console running we haven't used yet, and there's the info one, and there's this one. And if I want to, I can kill the kernel, close it. Yeah, so these are the kernels running, and if you go here, then you see these 2 notebooks are open, and here the kernel is running because it's green. If I go here and close it, the kernel, I set it this way, so if I close it, the kernel also is turned off. You don't have to do this. You can keep the kernel running, I don't know why, but it used to be the default before, that the kernel keeps running, and if you close all the notebooks, then you still have a lot of kernels running, which will take memory. Yeah? So if you want to change these things, there's a gigantic settings menu. You go to settings, you can change all kind of behavior, and if it's not enough, you can do a settings editor, and then you have many options. Most of the time, the defaults are okay. Sometimes they can be useful, like if you go to notebook, yeah, then I always set auto close brackets, so that when you have an opening bracket, automatically adds a closing bracket. That's very useful. If you don't like this, you can turn it off. and you can do many other things. Like you can add a ruler. Yeah. Now this is a code cell. Yeah. And I can say I would like to set a ruler, and I say I would like at 80. I would have this ruler, and now if I go back here. So should be there. Maybe I need to close my notebook and reopen it. So I can close it and reopen it. And now I have a ruler, and this looks strange. It's there, it should be at 80. Did I make a mistake? Oh. Rulers, 80. Oh. It should be, yeah, it's right now. It's here. Now you see here, if this very thin line at 80, so the recommendation, old recommendation of Python code formatting, don't use more than 80 characters, actually 79. Yeah. So then you can put a ruler here, and then you can see how wide your code is, for instance. So if you write text or something like this can be useful. I'm not sure why this ruler is here. You can also say view, show line numbers. They could be useful. So if your code gets longer, then you might want to see line numbers. Because if you have an exception, then the exception usually references a line number. When you have 20 lines, it's much better to know it's line 17 than try to scan yourself where things went wrong. Yeah. So this is very useful to do something, setting things up the way you prefer working with it. So of course, if you don't like the mode, there's also the dark mode. There's a dark mode somewhere here. Mode, language, console, text indentation, text theme. Yeah, there used to be a dominant theme, dark. So a lot of people like dark modes, dark background and white. So usually for presentation, this way around is better. Yeah, better visible. Good. You can do all kind of stuff with it if you like. Important is this question mark, and this question mark is useful. And now if I do this question mark, I get the help and add object. See. What did I do? Now I have cell number 1. So I closed the notebook and I reopened it. And now I start there at cell number 1, which is not good. Now add doesn't exist. I wrote it there, but this cell is not executed. This number 8 is still the old number. Yeah, so it's pretty messed up. So even if you mess up, you start again. So you can say kernel, and I can say restart kernel, run all cells. This is something you have to do pretty frequently with notebooks, because very often you can jump around between cells. And this can be nice, but can be a problem because you can execute the cells in any order. So the display order is not necessarily the execution order. So, but if you do restart and run all cells, then now it clears everything up, it starts again. You see now it starts numbering from 1 and everything is numbered. Of course now I have my output here, yeah, and then I get the help. Now I get the full help text, and I can also say as a double question mark, and if I say double question mark, I do get not only the help text, I get the source code. So this is not important now because I see the source code, but if I import this from a file, you can see the source code. So you can do this even for modules in the standard library. So if I say import OS, yeah, import, yeah, the import, so tab, yeah, if I type imp and then now the tab key, it gives me hints, import OS, which then I say OS changed here, yeah. So I can say question mark, and I do get the help what change here is doing, and hopefully I also get, hopefully I will do the right one. I do get the source code. I don't get the source code because change here is obviously written in list here. No, so there's no source code here because I'm obviously I chose the wrong form. There are some functions that should show me the source code, but most of them, yeah. So they just have a long list. They are all implemented in C, and if they are in C, they don't have a source code. But if this is a function in Python, then you see the source code also from a file. Yeah. But nevertheless, you can see the help here, and then you can find interesting help ones. Yeah. You see, this one takes parameters, and there's an interesting thing. The star. Anybody knows what the star means? Yeah, this means keyword arguments only. So if I call this function, yeah, I give a pass, so C colon something like a pass, a file name or directory name, and I can change write, change all. Yeah, then I have to know what this is. These are IDs, user ID and group ID, which is specific probably because I'm a Mac. On Windows this might look a bit different. Yeah, so this one I have to provide, and these ones are optional because they're provided. So if I don't specify them, and they will take these defaults. But if I use them, I have to give them as a keyword. I cannot say. I can give it as a fourth argument. I have to say dir underscore fd equals a keyword argument. Maybe a better example is sorted. Yeah, so if you do a bit Python, if you do sorted, yeah, this is a built-in sorted in Python, which takes an iterable, and now this one has even two, the slash and the star. And this means if I sort something, I can say sorted. Yeah, sorted. Let's make a string to sort a string. Do the Python. So I just have a string. Something like this. So now I say sorted and I sort the string, yeah, which gives me, now I get a sorted always returns a list. Now you see a second thing, if you use the notebook, it uses pretty printing. So pretty printing decides if a list is too long, I would like to display it like this. In most cases, this is nice. Like if you have a dictionary, nested dictionary, this pretty printing makes it much easier to read. In this case, okay, I don't want this is too much, so I can turn off pretty printing. Yeah, and you can say introduce a cell and say pretty print, and then when you turn off pretty print, now you get the standard display in Python. Yeah, so pretty print. What does pretty print do? Yeah, toggle pretty print on, off. Whenever you execute pretty print, you either turn it on or off. Yeah? Toggle means if it's on, you turn it off. If it's on, you turn it off. In the other direction. So that's what you do, and you get these ones, and then then you can use pretty print here. So I use pretty print, and now if I do this again, now pretty print is back on, and if I do it again, you see now what I'm doing. I execute the cells. This is number 17, and this is 24. Well, the other cells are not there anymore, but their actions are still there. So if they have any side effects, they are still alive. Yeah, they are still alive because Python has everything that you executed as long as you don't restart the kernel is still active, even if you don't see it. Then you can do something like this. Yeah. Yeah, and now I can say, I can remove this cell, I go here and delete this cell, and if I look at X, it's still there, magically. Yeah, so because I defined X, and the action that I delete the cell doesn't remove X magically, because the action is still there. And this can be very confusing. So what is the solution to this problem? Restart the kernel. Restart the kernel. So if I restart the kernel, so if we go to kernel, restart kernel, run all cells, yeah, and then it will complain that X is not defined, which is the right thing to do. Yeah, now I say there's nothing what you want, there's no X. That's what you want. Otherwise, it can be very confusing. they did analyze the GitHub. There's a lot of notebooks that don't run because they changed it afterwards, and they changed something that makes it invalid into some case. There's a new one out there. I haven't really explored. Anyone heard about Marimo? This is a kind of very similar concept, but they don't allow these things. So they have some interesting thing. I have to look at it. Yeah, they have a different concept. They then store things in JSON. Because if you go here and you look at your notebook, yeah, and I open it not with a notebook, but with an editor, then you see the raw JSON. So that's how the notebook looks like in the background. It's a JSON file. Everybody familiar with JSON? Yeah, it's a pretty easy readable data format. It reads pretty much like Python. It's called JavaScript object notation, but it's essentially very, very close to Python. There's some small differences, like true and false is lowercase, not capitalized. Yeah, and strings are always double quoted, and there's no distinction between int and float, and you cannot have a trailing comma. In Python lists, you can have a comma at the last element. That's not allowed, but otherwise it just looks like Python. We have a nested dictionary, and if you look at it, you can pretty much decipher what the notebook means. So all the cells are written here. You see everything I did when I defined my function is just a Python string. Yeah, everything is in here in the notebook in JSON, which it's nice because you can. I use JupyterBook, which is based on this. We can write whole documents in here because you can take these JSON and program on it. That's me. Okay. Sorry for this. Okay, so you can use a program that reads into JSON, and then you can go through the cells and do something. Yeah. So like you can have hidden cells and all kind of stuff which don't make it to the final document if you like. That's very useful as a tool because you can always look what's inside if you want to. If you're not interested, you don't have to. You don't have to know that it's there. So you see now I have this X, which is not defined. But my main purpose was I want to use sorted. Yeah, and if I sort something, you see now sorted sorts everything nicely alphabetically, but it sorts the capitalized letters first before the lowercase. That's how Python sorting works. Say I like this sorting, but I would like to make it case insensitive. Then you can use a function that Python provides, which is called case fault. Yeah, the case fault. So what is case fault? str.casefault. Yeah, return a version of string suitable for caseless comparison. Caseless comparison. So that's essentially doing the same thing as lowers. Always gives you the lowercase. There are a few characters in Unicode where this lowercase doesn't make sense. So usually in Germany I use a German example because we have special letters in German. So probably you will find your special thing in your language where things don't map too well to this one. Yeah, because in Germany we have a letter that exists only lowercase as Z. So if you turn it uppercase, it becomes a double S, and if you turn it lowercase, you lose the information. Yeah, it's strange. So, but if you use this one, it takes care of this. So somehow, yeah. So this is just for corner cases, but it gives you a lowercase version. Now I can say sorted, and when I sort this one, it doesn't work because I have to say key equals. So because this key argument in sorted is this is a key only. I can only use it as a key. Normally in Python, the normal Python functions, it doesn't matter if you use it. It's like in my add. Yeah, and I can say add 3 and this work. I could say add 4 and b equals 5 would be the same thing. So I'm totally free to provide both arguments positionally or keyword in position. So I can use keywords for both or combination. Of course, there's a few rules. You cannot do something like this. You cannot say A is 4 and then 5. This is not allowed. Once I switch to keyword, I cannot go back to positional because the position loses meaning. Yeah. And also, if I say add B is let's say 4 and A is 5. Yeah. Then it says now you supply A twice. As 4 positional and the 5 keyword doesn't make any sense. Yeah, those things are not possible. But otherwise, you're totally free. If you use this little thing in the help that tells you from here on, you can only use keyword ons. And until here, you cannot say iterable. It's not allowed to say iterable. This has to be positional only. So these two things have a big meaning, don't they? But it's important to understand the help. Then you know what these strange signs mean. So everything from a star on means keyword only, and everything to the slash means positional only. Yeah. So and now I can use this one, and then if I sort, see now everything is nicely sorted, or everything lowercase first, then lowercase, and then the uppercase and lowercase just get into line. Yeah. So this is what you can do with sorted. And this is also an important thing because this case fault is a function, and I can hand in a function into a function. So in Python, everything is an object. So the most important thing about learning Python is that everything is an object. And once you know what this means, you can explain most of the effects in Python. and functions are also objects. So I can hand in a function into the other function and can do something with it. So I can have a list of functions. Yeah? So if I want to, I can have a list of functions and then I can work through a list of functions. Yeah. And this can be useful sometimes because then you can test many functions without actually typing them out. You have a list of functions and you can apply this list of functions to a lot of things. Yeah. And now here I hand in the function, and this sorted calls this function for me and modifies the sort order. Yeah? It's called decorate, sort, undecorate. So it's 3 actions. First it calls this, produces this lowercase function, lowercase letter, then uses this lowercase letter for sorting, but gives me back the original value. Yeah? That's how Python sort works. And you can look at this here and you can work with it. Unfortunately, the help is a bit, doesn't really explain, it just says it takes a key function. Yeah, it takes a key function, which is a bit short because it doesn't explain what this function is doing. If you go to the Python help, it gives you a bit better introduction. So I don't have, I cannot search anymore, but if I go to python.org, yeah, and then you can go to documentation, Python docs, which always brings you to the most recent one, 3.13, and then if you type in sort, that's it, yeah, then you get the help, and then you see now it gives you a little bit more details how this works, how the sorted stuff works, and how you can modify sorting. Yeah, it also explains about this special methods which we don't cover here, so you can make your objects comparable. Yeah, and here it tells you that the key function is a function that, and they use a lower example instead of the case sort which I used here. Good. This is the basics of those tools I show you, those magics. So we have this Python magics. Let's just check what I have here. So we have the help, and we have a lot of these things what you can do once you have to get the help. So you have ls, cd, and a few other things. So these are magics which are very nice because many of these magics, they are independent of the operating system. Yeah. So cd means change directory, and this change directory takes command line options. So if you want to, you can modify the behavior of the cd by providing some of these dash minus something. Yeah. Quiet, which suppresses the output if there's usually over echoes back where change to, and if some of the other ones have more of these options. Yeah. The nice thing is these are operating system independent. Sometimes you want to do something that it's not defined for every operating system. You want to just call through the operating system. I can do this, and this would now call ls on the operating system. This wouldn't work on Windows. On Windows, you would have to say !dir. Yeah? If you start with a normal CMD Windows, if you have PowerShell, then ls also works. Yeah. So then I could do something like this. This would be a special command that doesn't exist, not necessary if you don't have it installed. And I could now use tree, or let's say tail. I want to use tail. There's a different command, and now tail gives you the last n lines, I think 10 lines or so, per default of a file. So this is a special command that I don't think exists on Windows. On Windows this wouldn't work because exclamation mark calls operating system shell commands. To be more specific, everything shell allows will be available, and you can use it from the shell. So you can do pretty much everything you can do from the command line from a notebook if you want to. And sometimes it can be useful. Of course, you can incorporate it in your workflow. You're not limited to those percent things. Always use percent things if you want, because they are more platform independent, and you don't have to put it down into one thing. So we have this alias thing I will jump over. Also the bookmark thing. So tab completion, we saw already. We have tab completion whenever you type something, then this one does help you tab completion. So if I have name 1 is 1, name 2 is 2, Yeah, I said one, didn't type it. So if I start typing N and then a tab, I do get everything that starts with an N. And this includes, this includes, you see, this is an instance, this is a Python object. This is a Python built-in function next. These are Python keywords, non-local and not, and this is a magic. Yeah. So if I would type, type capitalized I, now everything is a capitalized I, which also includes the file name. So this one gives you a lot of things. So the file name doesn't make sense as it is here. You would need to put it in a string or something. But this can be useful because if you have a long file name, you don't have to type it. You just type the first two letters and then tab, and then it gives you a suggestion if it matches. Yeah, so all kind of stuff. Yeah? And if I type along, you see now there's only two names that match NA because my name 1 and name 2, and if I select it, then I get this back. So this is tab completion. You can also install extensions. So you can install an extension. One is for language server pages, which anybody knows, LSP. These give you advanced syntax highlighting and more help. Yeah. So if you really want to, you can go here and you see I have pigments installed. You can install more extensions. You can install them through here. You can also usually install them as it's a plain Python package. Say pip install extension name, restart your thing, then the extension will be there, and there are extensions for all kind of stuff. Yeah. So I can install, if I want to do Rust, I can install extension for Rust code highlighting and so on. Yeah. Pigments does it already most of the time, but also an LSP for Rust, which connect to the Rust and gives me more interactive help. So there's a lot of extensions for different purposes. If you want to, the installation is much easier. The problem is all these things are written in TypeScript. TypeScript is a superset of JavaScript, but you don't need to know any TypeScript. Yeah, to the extent because everything else concerns the GUI is TypeScript, but as a user you don't have to know anything. You just install it and then you can use this one. Like I installed a spell checker. If I write a lot of text, spell checker is a good idea. So otherwise I have a lot of typos. Yeah. So then you have a spell checker that shows you in the markdown cells if you have any problems with spell checking. Good. That's something very useful. So you can have more what you can do here. Good. And of course, coming back to Python. So once you develop something that gets bigger, then you can make a file which is a Python file, and I can put my add function. So I'm too lazy now to program everything. You can actually, I can do things. I can copy paste. I can also save it directly from a cell. But let's do the copy paste one first. So I go here, I go to my file, yeah, and then I save my file. Module add. Just give it a different name. Yeah? I can do something like this, and this would be now a Python file, and I can import my Python file here. And that's usually a good workflow. I can say import module add, yeah, and I can say module add dot add, and I can use my function from there. And this would be the first step to make the things more useful. First, you start developing in the notebook. You develop a function and say, now the function is good enough. Now I move it into a file, and then this file it's a standard Python, and then you can do all the tools that you have in Python, but you can still use it from the notebook. Yeah, you can still use it from the notebook and you can work with it. It's a small problem. If I go in here, yeah, now if I say mod add, double question or question mark, I do get no docstring. There's no docstring for the module because the module doesn't have a docstring. The function does have a docstring. Yeah, but I forgot the docstring for the module itself. So usually when you write a file, the very first thing should be a docstring. You see, I use this auto close brackets that automatically adds the closing three once. Yeah. my functions. It's not a great doc string, but it's a start. So that's even better. Okay, good. So we have a doc string officially. So now formatted the way it is. And now I want to look at my doc string, and I go back here, and I put 2 question marks at my module. Yeah, and you see there's no doc string. It didn't pick it up because that's how import works. When Python imports things, it does it only once. Because when you import it, it goes into where? Now it's Python basics again. Then you have something called sysmodules. Yeah? And sysmodules is a dictionary with a lot of entries. That's why I don't show this big dictionary. That's not helpful. And everything you import will be in this dictionary. Yeah? So if I say mod as a string, mod underscore add in sys.modules. Hopefully it works. Sometimes it has a bit different opinions here. And it has to be a string. So a string is like this, not a backticks. I wrote too many markdown things. So it is true. So that means whenever I import this module, it looks in this dictionary and finds it. So a dictionary lookup in Python is very fast. It's one of the fast because they are used a lot. And this is it's in background. It's a hash table, technical thing. So lookups and hash tables are designed to be fast. And that's what happens here. So the lookup and hash table is orders of magnitude faster than a physical import. Because a physical import can be a very complicated thing in Python. There's a lot of different options. You can import from zip files and from network drive and whatever. And then there's a lot of customization until it finds a module potentially. Yeah. And this one is much, much faster. So every import works only once. And this can be a problem. What's the solution? Restart the kernel. So it can be, yeah. Or, okay, that gets tedious if I need to restart the kernel again and again. I can make a new notebook. Yeah, I make a new notebook, and I call this one no restart. So whatever you want. So and I use magic and I use percent load extension. So you can load extend. You can write your own extensions, by the way. These percent sign I wrote my own. It's not that difficult. Load extension, and this is one called auto reload. Yeah, and this auto reload, if I enable auto reload, there are different modes. I say all. Yeah. So and now if I do the same thing, I import my module add, and I say module add question mark. Yeah, and I get this one. I go back and I modify something in my doc string. Yeah, and more. Yeah, I save it. Go back here and now do the same thing again. And see now it automatically imported everything in the background. So this is something that helps to solve this problem to some degree. Important you have to do this, you have to load the extension before you do the import, otherwise it doesn't work. Otherwise do it too late. So that's always the first thing. And it can be useful if you read the help, you see it's not foolproof. There are quite a few corner cases where it doesn't work, but for my purpose usually it works. You see it's pretty long help. Yeah. Yeah. Auto reload takes a lot of options. Yeah. And you can turn it off. All used to be number 2. Every time I execute a cell, it re-imports everything. If you have a lot of diff libraries, it might be a bit slow, but you can also say turn it on and then whitelist everything you want. Yeah. So you can have this whitelisting. Should be explained somewhere how this works. Yeah. Then you say only this module is supposed to be whitelisted. There's a lot of explanation down here. Yeah. So you can read this explanation how this works, and a lot of options. Most of the time, all is good enough. If it gets too slow, they have to think about doing something else. Yeah. Explicit only modules imported with, so you have to import them with a special thing, and only these ones will be like only my module. Because if you reload NumPy and pandas and so on, of the time, that might get a bit slow. Yeah, if you, because they will do this for everything. Yeah, and if you don't change the source code, there's no need to do this. But it can be useful. So now we have a tool that kind of combines the advantages. You can do the development in here, and you don't have to do it in here. You can use your Visual Studio Code or PyCharm to develop your files, and then you import a notebook and work with them. Yeah, so you can do your interactive exploration in the notebook, and the development of something more durable in files. And this is important because people often complain notebooks don't work, but this is very often you use the wrong tool for this job that you're doing. So you have to say, what are the advantages of this tool or this tool, which one should I use? And JupyterLab is just one tool, and it can be very useful to explore something. If you write big software systems with it, it's usually not the way to go. No? No. So if you go just around the corner to buy something, a bicycle is good. If you go a long distance, you want to use some train. Yeah, it's always the tool for the right job. Then that's important. Good. Any questions so far? So I do have some exercise in here, but to have so little time, I think we kind of skip the exercise a little bit. So you're always welcome to work along. And if you have any questions, always ask questions, because you only have half an hour left anyway, and I want to show you a little bit what you can do with it. So, as I said, these notebooks, they have a memory. They can, I don't know if I said it, but they do have a memory, and you have all the input history, for instance. So everything you typed in, as long as the kernel is alive, is in the list. And now this input history doesn't look as good because I turned off my pretty printing and I turned it back on. Yeah, and you see, this is the input history. So everything I ever typed is in the list. Since we start this cell number 1, this index 0 is always empty. Yeah, so you can index into list with the cell number, and you get whatever you typed in the cell. The same goes for the output history, where the output history is a dictionary, because not every cell. So it's pretty long now. Yeah, because not every cell has an output. Only cell 1, 3, 4, 5, 16 have outputs, others don't have output. So that can be pretty useful to see what happened. Yeah, just to see what happened. So you can also use the bar. I forgot. There's one command. It's at the very end of my good memory. Yeah. Is to find. I will come back to my memory. We'll see it. So there's a few other things you can do. You can save a cell. So if you want to save one or more cells, you can use save command. So instead of copying, pasting everything around, the save command lets you save things. So if you save ? And again, gives you a lot of options what you can do. You give the options, the file name, and then the cell numbers you want to save, and then it will save the content of all these cells in one file. Yeah. So if you say everything, you save the whole file, or you can select those ones you want. Yeah. If it exists already, we'll ask you with F4, you can overwrite it. Yeah. It will overwrite the file unless you say append, then we'll append to an existing file. So this is not very important, but can be inconvenient if you have cells and you have something like this. So instead of doing copy and paste, you can select cells and save them to a file. Yeah? This can be useful to work with, and you can do this. Good. I always need to check a little bit. I don't forget anything. Exceptions. It's important. So if you have an exception, yeah. If I divide 1 by 0, yeah, then you do get this exception. I do have an example here. So if you downloaded it, you will get this this bug file. So if I copy this bug file, so I have this. Yeah. So actually, I can do this directly. I can go. So to get it imported, I need to be in the directory. For now, I can say import bug, yeah, and then I can say bug dot do I have a main there? Yeah, so I have this test. I can do it differently, yet another way. So I can import things, but I can also run them. I can say run my file, and I can say run my file bug. Yeah, and now it runs the whole file without importing it. But in my namespace, because I want to do this to get a nice traceback. And this is a standard traceback in Jupyter, and if you compare to normal Python, it looks different. So it's the right background, but also it has more information because you have different modes. You have X modes to specify the output level when you have an exception. So you can say X mode plain, and this would be the standard X mode that Python offers. So if you use standard Python and you run your thing, you get an exception that looks like this minus the coloring. Yeah, so it just tells you this one. This is a standard thing. This is called context. So in addition, it gives you the line numbers and a few lines before and after the problem, which is useful. Yeah. So if I say X mode again, it toggles to context. That's what we just had. And you say X mode again, it toggles to verbose, and verbose now means it gives you even the local variables. You see now it lists these two local variables, and this is very helpful because I have a function that divides x by y, and if I divide by 0 I get an exception. And here it shows me the values. It divides 10 by 0, which is not healthy, yeah, and then I get this problem. And this can be very useful because if you see the local variables, when you have a problem is not too complicated, it might solve your problem already. And this can be done here directly without doing any kind of setting breakpoints and stuff like this. Yeah, that can be useful. And then you have this output ready. Just use the X mode. This can get very long. If your program is complicated, a function imports a function, and so on, then you get many pages of output. That's why you don't want to turn it on per default, but it can be useful anyway. Yeah. So this is an easy, simple debugging tool that's usually pretty helpful, and you can do something here in Python. You can also turn on the debugger. Yeah. If you want, you can say debug. Yeah. And there's always a tool version. We come to this debug with 1%, and then this brings you in the interactive debugger, and now I can look at X and Y. Yeah. So now you can do this IPDB, which gives you a few basic things. If you ever use the debugger, you set a breakpoint and so on. This one jumps directly where the exception is. So post-mortem, so after the fact, you can turn on the debugger and start debugging your program. Yeah. And then you say Q for quit, gets out of it. So it's not very fancy, but it's pretty good. You can see here, there's also a debugging mode, but you need to install a special kernel. Sorry, so that was a different name for kernel. Actually, I haven't even done this one. This would give you a nice graphical debugger. So if you want to do debugging here, there's also some other ways of doing it. Yeah, but we don't have time to look in this. But as you see, you can set breakpoints and you can do all kinds of stuff. Nothing is shown here because I don't have the right kernel installed to run it with. Yeah.
So how would you debug a function that you have saved into a module and then imported and then it gives an error? You would use this?
Depends. So it depends how your workflow is. So if like the web developers don't use notebooks at all, of course then you use your PyCharm. So if you really want to do something serious, use PyCharm or other tools. But here, when it's something simple like this, then you might be able to solve it immediately. So if something you can solve in a few minutes, then notebooks are good. If it gets really complicated and you do a lot of investigation, then you can use more elaborate tool. So it always depends. So if you don't know how PyCharm works, it's not helpful because you have to learn first quite a few things until you get. If you know PyCharm and use it, by all means, or Visual Studio Code, or even Visual Studio, it's very good. It's one of the best products from Microsoft, I think, Visual Studio, but it's pretty complex. It's really complex, so you have to learn a lot. But once you know, it's a very good tool. Yeah. So there's always different people have different preferences, and you have different use. It can be done here, yeah? And because it's very interactive, and you can always jump in and write your own tooling inside. And to my knowledge, sometimes you need, if you have especially if you have scientific programming, you have a lot of numbers, then going through all the numbers and debugger is not useful. You have a million numbers and you go to a debugger, a million steps, it's not helpful. You need to write some tools that you need to load this in a data frame, append this data frame is sorted, or something, usually. Otherwise, it doesn't make a lot of sense. Yeah, good. So you can use debugging, which is useful. I would like to show you a few more of these special ones. One of my favorite ones is time it. So very often you would like to, or at least I, measure how long things take. Like I develop a program, I have an algorithm, I have two different alternatives, A and B. Which one is faster? Which one is faster? Yeah. So does it matter? And it can be pretty tedious. There's a module in the standard library called TimeIt, and there's a which you can use, but there are quite a few steps until you get something done. Here you have a magic, yeah, called TimeIt, and this uses the time in the background, and this measures how long 1 + 1 takes on my machine. So it took quite a while to execute it, because measuring 1 + 1 is not that easy, because it takes about less than 4 nanoseconds. You cannot measure less than 4 nanoseconds, impossible. That's why the solution is, don't do 1 + 1 once, do it 100 million times, yeah, and then divide the time by 100 million. It's like if you have a letter and you want to weigh the letter on your scale by your bathroom scale you put yourself on. The bathroom scale is good between like 30 and 120 kilos or something. Yeah. So a letter is a bit too light, but if you have 5,000 letters in a sack and you put it on and then divide the weight by 5,000, you get the average weight of a letter, which is kind of correct. Yeah. Same thing here. And then to be statistically fine, you repeat the whole process 7 times. That gives you mean value and standard deviation. Yeah, if the standard deviation is small compared to this one, that's a good idea. Yeah, so and this is one thing, and I can also say 2, and I can say time it. Yeah, and I can say A equals 1 and B equals 1. I say A plus B, and it will take longer. Of course, now it does the whole cell that many times, but now I have all the assignment and then the resolution. And this one calculates the assignment, and I can also say I want to have this one, but I want to have the assignment done up here. So you can do this. Here you have to use some color. Now the assignment is only done once, and then this time it only measures A plus B. Yeah. And it should be a bit faster because the assignment analysis is faster, obviously. But this one, if you assign A plus B, it takes about nearly twice as long as just using literals. But if I use 1 + 2, I can write 2 directly. I don't have to do anything. Yeah? So I have to do anything. So this is very useful, this TimeIt. And this TimeIt also has a lot of options, and I use it quite a bit when I look at if I have 2 different ways, should I use a list or dictionary for this purpose? Is there a difference in time? No? And if there's no difference, I'm free to use whatever. If the difference is big, then I say better use a faster one. Yeah? So it's not always necessary, but then you write a program, you never know if you give it a program to somebody else. You assume people use it as a small list with 100 elements, but they use a list with 100 million elements, which changes the story quite a bit. So you have to can check if this still makes sense to use a program in this way. Yeah, those kind of things is very useful. And TimeIt also has a lot of options. So with TimeIt you can question mark. You can. I jumped to my notebook. Okay, this is a question mark of TimeIt. You see, TimeIt is pretty long. Yeah, so this is a question mark of time. So time is pretty long. You have a lot of switches, so you can adjust all these kind of numbers, everything. And you also get a result object, and you can work with the result object. So you can incorporate the results of time in the program that usually you want to time multiple functions. Yeah, I want to call this function, this function, this functions. So you can write a small tool around it and can have 100 functions timed and compare them or something. That's not too much work most of the time. That's what you want. You want to automate these ones and reduce the manual work as much as possible. Then you can extend it, say if it's 10 functions or 100 or 1,000, it doesn't matter. In the end, I get a report and get it sorted by the time it takes, yeah, or different parameters to a function or something like this. Yeah? This can be useful, and of course, Python has a reputation of being slow, which is true to some regard. Yeah? So if you do numeric computations, it's pretty slow. That's why you need C, C++, Fortran extensions. But a lot of other things that are slow are very often algorithmic. And if you change your algorithm, you can make your program potentially much faster. Yeah? But you always need to check if it has an effect. And if you know, I work only with 12 months in the year. On the year, we'll never have more than 12 months, then you don't need to optimize things because it doesn't get bigger. The speed is usually concerned if data get bigger. And data get bigger for scientists. Yeah, you start with a few megabyte and you end up with a few terabyte in the end, and then you might need to change your approach somehow. And there are many different approaches, and Timeit is one small tool that can help you to measure your progress if you have these tasks at hand. Good. So Timeit, I just jumped here a little bit. Finding bugs, that's what we did here with an example. Yeah, there's some things, measuring runtime. So I have another example here where we actually do an analysis. I skipped this a little bit, but the same thing, you can use Timeit in different ways. And you can also use prun, and prun gives you, you call it a profiler. Yeah, Python has a built-in profiler, C profile, and prun is a Python interface to use a profiler. And this profiler runs your function in the background, yeah, and checks what happens. It can be useful because then you get a breakdown. So there's a lot of things going on in the profiling space. Python has a C profiler. It has a profiler written in pure Python C profiler, and there are tracing profiler. This is a bit problematic because they slow down your program quite a bit. There's a very new profiler in Python 3.14. It's a sampling profiler. They do very sophisticated things and don't slow down your program. And there's many third-party library packages, Scalene and so on. So I teach more than a whole day just profiling. Yeah, this big topic can be interesting if you need to improve your program. Then you need to know. Very often, not the whole program is slow, only certain parts. Which one is? What is the problem? If you don't know the problem, it's very hard to solve it. So you need to know the problem. What do I need to solve? And profiling is one good tool. And prun is in here and can be good enough. The problem is it can only resolve on a function level. So I cannot look inside a function. I can only know this function takes this much time, this function takes this much time. But if the function has 20 lines, I don't know which line consumes how much time. Other profilers like Scalene give you a line-by-line breakdown. Yeah, so that's a different story. So this is profiling, but it's very interesting because it has a profiling, and this is actually what I want to show you who's defined. It's called who. So I forgot the who. Yeah. So if you work a while with your notebook, then you can say who, and you do get all those names I defined or imported. Yeah. OS is imported. This is also imported, but the other ones I defined. And then you get these ones. And if you say who's with an S, yeah, then it gives you a table and it shows you what type the functions are. And if they are numbers, you get the value. For other functions, you get some kind of representation in one way or the other. Yeah. So that's, yeah, so you have this modules. You always get a file name for a module, and a few other things you can have.
Is there also a way to check which of the things that I imported I'm really using?
Not that I know of.
Okay.
Yeah.
Sometimes I import stuff.
Yeah. So if you do this, you use PyLint. So there's tools around. There's other tools. I don't think there's an extension for PyLint here, but this because complicated PyLint works on a file level, and if you have PyLint shows you unused imports. Yeah. So PyLint is a command line tool. So you would need to say, I would need to add PyLint here. So I use Pixie, so I don't use so install PyLint, and I can say Pixie run PyLint, and I give it my file Jupyter bug. completion doesn't work for some reason here, but so now PyLint tells me my file is perfect. So but if I now go to my bug, when I just import something unmotivated, yeah, it should now tell me that I have repeat this one, unused import OS. And so PyLint is a tool. Another tool that's used nowadays, it's rough, which is much faster. So PyLint can do more than rough. Yeah, and PyLint gives you a lot of things that go way beyond formatting. Yeah, so unused modules, potential problems, yeah, mutable default arguments, and those kind of stuff. It gives you a lot of things. So the new kid on the block is rough, which is trying to replace a lot of tools, but there are still a few things PyLint can do rough cannot. Yeah. Rough has a big advantage, it's much faster, so you can run over big code base. Yeah. So I can check if this one rough would pick it up. Yeah. So try the same thing. So I have to say pixie run rough check. Yeah. And now it doesn't like this. Okay, this gives me has some other ideas to say it doesn't like this empty spaces there. No? But it also gives me this OS. Yeah. Import unused. So it has a little bit different. This changed quite a bit. There's a new one. I didn't see this colorful output this way. Yeah, there's a new version. So it gives me a few things, and then it complains that I have this. Why does it complain? Ah, yeah, maybe it finds out that I divide by 0. Just with online docs should fit on one line. Okay, this is that they have a different style options. They want to have this on one. They want to have the doc string on one line. So the PyLint doesn't mind here. So this is a different problem. Yeah. So and now it tells me import but unused. Sometimes if you get very dynamic, they cannot do it. Everything is static. So in Python you can always track these tools by do everything dynamic. You can generate code at runtime and do something, and then those tools are out. Yeah? So, but do it only if it's necessary. So I teach a lot of meta programming stuff, but this is just more academic for fun, or if you really need it. And very, very often you don't need it. There are better ways of doing it. Yeah? And then those tools won't cut it. Then you have to turn them off because they don't understand what they're doing. Good. Any other questions about JupyterLab, Jupyter Notebook? Anything you want to know about Python? So we have 10 minutes, and maybe it's a good thing to go with questions. Yeah.
I have another question, and I don't even know if it makes sense, but is there a way to render reports from Notebook?
Yes, there's many.
Would you recommend doing this?
Actually, I'm doing. There's different ways. The easiest one you can export directly here. Export and save as, and you see you have different formats. So now if I say PDF, you get the answer to LaTeX and you get the PDF. Yeah, you can also different formats. You can import as Markdown and so on. If you have more needs, a system I use is Jupyter Book. So they just come up with the second version because the first version so that's a bit small. Yeah, Jupyter Book. Yeah, build books, but it doesn't have to be a book. And they have a new version out to 0, which has a lot of improvements. And they use Mist. Mist is an extension of Markdown. And essentially gives you the features of research or text, I would say. So this is designed for writing scientific papers. So list of references and figures and all that stuff. Yeah. So this Mist Markdown is extended, and it's good enough to write a paper. So you can write a paper in the notebook. If you have a paper with a lot of code, a lot of interactivity, because you can program the whole thing. Yeah? So you can result that you compute can be added automatically in your text. Yeah, if you copy and paste and you change it all the time, that's not good. Yeah. So now the new version is out to 0. I haven't even moved it still, and still not even available on Counterforge, I think. And they changed to Mist, and they also use types. So instead of LaTeX, anybody use types? I just use that. So this is better than LaTeX, I would say. But it's everything's pretty new. But the old one, and this one is a big one. So that might be a little bit overkill in the beginning because it has a lot of options. You have a table of content, and you can put many notebooks together to one document. And you can render as HTML, PDF, other formats if you think so. Yeah. So, but the easiest one is just export it from here. Yeah, and then you say File, Save As, and you can choose one of these options. So if you want to give your notebook to somebody who doesn't use Jupyter, can you save as HTML? So it looks exactly the same, but it's not executable. But it's good enough for a lot of purposes. If you generate PDF, then you get vanilla PDF. Really, you want to have some formatting. Then you have to just get the LaTeX and then work with the LaTeX. And you can say LaTeX if you want to, and then you use your LaTeX skill around to change the formatting, which can take a lot of time. So, there's a lot of options here. JupyterBook is probably the most advanced, and they explicitly go for scientific publications. So they have a lot of built-ins for scientific publications. Good. Other questions? Any basic Python questions you would like me to cover? So what's the take-home message for the Python? What's the most important thing in Python? Everything is an object. So if you take this home from the course, then 90 minutes is worth the time for sure. So everything's an object, and when you're in Python, you have objects, and you can work with objects. So if I do something like if I create a list, yeah. A list. The fastest way to create a list is write list, range, something, yeah. Then you get a list, and this list has a lot of information, yeah. So you can do the help, you get the help, which is, by the way, in Python, if you're not in, this is the equivalent help in, that's different. Looks different, not equivalent anymore. Well, used to be the same, but now they have changed it, obviously. Yeah. So this is a built-in help in Python. It has nothing to do with a notebook. And you have this one, and then you have a lot of things you have about the object, like dir gives you all the attributes. So if I say L dot, when everything that's possible is in this list. Yeah. So this is introspection, and this is helpful, and this works for any object. Yeah. You always can introspect all these objects automatically if you like, for some reason. And this not only works for the built-in list, it also works for pandas data frames and NumPy arrays and all kind of stuff. Yeah. So dir is pretty useful, and very often we only want to know how many you have, and then since it's a list, you can say length, and you could know it's 48 attributes. And as you can see, there's a lot of these special ones. These dunder. Anybody knows what these guys are with these underscores in front of the end?
Special methods.
Special methods, yeah, special methods. So they actually not supposed to be used directly, but Python uses them internally. So if you use a special syntax, those special methods are used. So if I have my list, and I have to say list index 3, I get something. And this is the same thing as using the underscore one, yeah, and I use get item, yeah. So this one translates, yeah, because here I use square brackets, and in the background this happens. So don't do this yourself. But that's what Python is doing. So, and this is very often called operator overloading, which is a bit limited because this square bracket is not an operator. I'm not sure. It's some piece of syntax. Yeah. So, and you can write your own class and override this method. So you can provide your own class that does something when you use a square bracket. Whatever you want. It has to make sense, hopefully. Otherwise, you're totally free to do anything. And then you have to look how this get app is usually implemented, yeah, and this is basically the special methods. So, and very often we get these special methods, but you don't like them, you don't want to see them. How do I turn off the special methods? I filter them, and the easiest way to filter them is list comprehensions. Yeah, and I say name for name in list. This gives me exactly the same. I didn't gain anything, but I can say if not name dot starts with something with to underscores. Yeah, and this would filter out if what did I do? Starts int object for name in, yeah, I forgot the dir. Yeah. So I made it the wrong way. So okay, now that's what I wanted. So the dir has to be inside, of course. I dir first, and then go over the whole thing, and then I take only the ones I like. Yeah, and I get a list back, and I can filter out these things. So list comprehensions is a very core thing of Python. List comprehensions are optional. You don't have to use list comprehensions, but they can be useful. So this would be equivalent to, last thing, result is equal, yeah, for name in list, in dir list, yeah, if not name dot starts with, so now it knows that I have the starts with two underscores result append. Yeah, so this would be totally equivalent. Name. And you see, this would be totally equivalent to these two cells. So the list comprehension is always optional, but it's used a lot in Python. People like it, and it's nothing else but this loop. And filtering something is a very common use case for list comprehensions. Yeah, this is something you want. And now we can apply it to introspection. Now, if you have a new library that's big, you can go through your objects and can filter your objects and see what do these objects provide automatically. You can always go to the documentation, but this can be tedious. Here you can do it live, and you can say, okay, I have many objects, and I write a small program that goes through all the objects and does it, and I get some statistics, whatever I like. So sometimes it's a little bit, yeah, a little bit like a game, but it can be useful to get some things. So do different classes have same methods or not? So you can mix and match and all kind of stuff. Everything is possible here because in the end, how all this data are stored in Python? What data structure does the Python use to store all the names and the objects? Dictionaries. Everything is in a dictionary. So if you go into any object, anything time you use a name, Python looks in a dictionary for a string and finds an object. Yeah, so therefore, if you do something like if I say vars, for instance, vars on list, doesn't work. Yeah, it's a built-in, so the vars looks for dict, and the list, it's a built-in, doesn't have a dict. So if you write your own class, it would work. This one doesn't work. Yeah, it seems like an optimization. Yeah, that's not nice. So if I would need to build the same thing, I would need to go to dir and then get the object. But usually this one, if you have your own class, this should work and you get all this. Yeah. So there's no variables on my add, there's no attributes to my add, but it works for any object. The worst thing that happens, you get an empty dictionary, but it's a dictionary. Yeah? So in this case, there's nothing there, but this one gives you everything. So everything we did so far, whenever I type something, yeah, if I type my x, which doesn't exist, or anything else, if I type my add, and this add is a string in a dictionary, and in what dictionary? In a dictionary in globals gives me my global namespace, which is a dictionary, and it's there. Yeah. So lang is a lang of globals. So it's pretty big. So I want to show you it's a dictionary with everything I did in my notebook is in a dictionary, and I get this dictionary for the global namespace. Actually, locals should be the same because locals and globals the same. Not exactly, there are some differences, I have to check which one. Yeah, but everything in the background is dictionaries, so if you want to do something, spend some time and learn how dictionaries work, is very useful because everything in the end is a dictionary. So check my watch. So it's 10 minutes over time. So officially we're through, it's coffee break now. You're welcome to ask any questions. This was kind of a fast tour. Hopefully prepared you a little bit for the other tutorials. That was the main purpose. So then you know how to use Jupyter. Of course, pretty much all other tutorials will use Jupyter in one way or the other, and then they will use some of the magics and a few things here and there. And very often they give you notebooks, and then you know how to handle notebooks and how they stored and what to do with it. And maybe you learned a little bit about Python stuff, which is only scratching the surface. Obviously, in 90 minutes we can really dive too deep. If you have any questions, you're welcome. Otherwise, thank you very much for being here, and have a very nice Euro SciPy. Good.